So let us see they can have to calculate the critical values and giving the level of confidence, let's say 0.01, and that is for the rift delta. So now just have to make sure that you have a normal table before you, because that's what I'm going to use in this lesson. So I understand you know what is a normal table in this case, and also you have to understand that the normal table actually gives us the values to the gives us the area to the left hand side of the curve. So take note of that. So now, since we are told to have the critical value, and that is a left tail test, that means that is pretty fine okay with a normal table, because the values are actually the value of the critical value will have. In other words, we just have to literally go into the table and look for the critical value with the alpha that we are being given that way. And mind you, alpha is said to be the level of confidence. So you understand what it is about, but take note of that. So what is the critical value with respect to the alpha being given as 0.01? So now make sure that you have a normal table by you, and you should have to check within the normal table actually the value corresponding to 0.01, or the one which is much closer to 0.01, and I'll be able to have the critical value in that way. And as for me, the value which is much closer to 0.01 on the normal table has been given as 0.0099, and this is the value which is much closer, that is to this one. Now if I tend to check it out, that should be up here, and also should be in this case. Now I happen to have what is the value corresponding to this one in this actually in this column for the normal table. You see that we'll have it as now should be negative 2.3. So which means the critical value will be given as negative 2. Let's say a 3. What is the value up here? Actually, the value up there it is given as should be what here? 0.03. So which means upon combining this this value and that one, we'll have it as negative 2.33. So that is the critical value. Then I'll have to present that one on the a normal curve. That will be looking at this. So now this is the normal curve. We'll have this one as the horizontal x-axis, and we'll have this as the normal curve. And mind you, this is the center, and basically it is given as 0. Of course, you don't need to indicate that one, but just have to know that that is the center which is given as 0. So the values to the left hand side of the center are given as the negatives, while this side are given as the positives. So now the critical value that we have, it is a negative. It means it is located within this side. So which means you have to do it this way. So have it as this. So this is the value, negative 2.33, and since it is left out, we'll just have to shade this side. So now this is a critical region, and this is non-critical region. So take note of that. So now what if we're being given the alpha 0.10 and also the same rift delta test? How should we be able to have the critical value and shade the a critical region as well as the non-critical region? In other words, you have to show the critical region as well as the non-critical region. So now principle remains the same. We'll go into the normal table and look for the value corresponding to 0.0 should be 0.10 or the one which is closer to this one in the actually normal table. So make sure that you have the table before you. And the value which is much closer to this one on the actual table is given as 0.1003. So this is the value which is much closer to that one. And what are the corresponding values on top here and also on this side on the table? So in this case we have it as, we have 0.08 actually up there, and we have the other side, the value which is being given us now should be a negative 1.2. So we have negative 1.2. So now which means the critical value upon combining we'll have it as being given as, so it should be negative 1.2, actually 1.2 should be 8. So this is the critical value, and we should have to represent it on the normal curve and show the critical region as well as the non-critical region. So this knowledge will be very important when we'll be expressing much about the hypothesis testing. We use this knowledge. So in this case we should have present the normal actually curve. So this is very important, and we know this is the center in the given cell. So since the critical value is negative, it means it is located within this side. So it can be somewhere here like that, of course. So since it is left out, it means we'll have to shade this region. So this is the critical region, and this is the non-critical region. So take note of that. Of course, we should have to indicate the value negative 1.28. That is corresponding to this one. So whenever we have been given that, it is actually left out. So we just have to go straight on the table and look for the value which is closer to that one, or can be, if we have the value which is exactly that one, that is also the best idea to go for. Then I should have to calculate the critical value corresponding to that value upon looking at the value in this case and also the value actually up here, then combine the two values. So now how about if we have it as actually a light cloud? How should we be able to have the critical values if it is a light cloud? How should we be able to have it if it is light cloud? And mind you, the normal table that basically gives us the area to the left hand side. So what if it is to the right hand side? How should we be able to have the critical value if that's the case? Let's say we have alpha is equal to 0.05. Let's say light cloud. Let's say that's the case. What would be the critical value if that's the case? So now there's something you have to understand about the normal table. That should be a normal curve. Let's see, this is the normal curve, and that should be that. Let's see, this is the case. You should have to understand that the overall summation of the area actually for this curve, it is given as 1. That's the summation. Actually, that is the overall area. But the table gives us the area to the left hand side. So that's the area that the table gives us about. Let's say, for instance, we have, let's say, no, it should be this. Let's say we have, let's say this is the critical value given as A. And we are told to have the area which is in this side, or should be, let's say we are told to have the area which is on this side. How should we be able to have the area on this side? So now you understand that since the table will give us the area towards this side, it means for us to have the area of this side, we'll just have to simply have to subtract the area of this side, and from 1, then you'll be able to have the area of this side. In other words, we use the complementary process to have the area of the right hand side. since what we have on the table, it is the area to the left hand side, but we know that the summation of the two areas will be given as well. So since we have this one and we have the total, we'll be able to have the area of this side, which is simple as that. So now, which means now what will happen is that first thing we'll have to subtract alpha from 1, so which means we'll have 1 minus 0.005. So in that case we'll have it as 0.95. So which means we're going to have the critical value corresponding to this, actually corresponding to that value on the table, since it is light out. And we understand that the table gives us the area to the to the left hand side, but we need the area to the right hand side. So in that case we'll have the complement of 0.005. So what is the area, what is the critical value corresponding to 0.95? So if you may tend to carefully look on the table, so what would be that one? And of course the value which is much closer to this one, and on the table is given as 0. Should be this. We have it as 0. So what is that one? 0.9495. That is the value which is much closer to this one. And of course it is not exact true. So what is the value up here and what is the value this side? So if we tend to carefully check on the table, so we have it as 1.6. So this is 1.6. And what is the value up here? So that one is being now given as, it should be 0.04. So if we combine the two values, we'll have the critical value that will be given as 1.64. So that is the critical value. And the rest have to present the value on the normal curve. Don't forget about the normal curve, because it is the one that will give you a guide whenever we'll be dealing with the problems to do with hypothesis testing. So this is should be normal curve. So that is, so now since the critical value is positive, it means it is located within this region. It can be somewhere here, 1.64. And since it is light out, it means we'll have it in this case. So this is the critical region, and this is non-critical region. So take note of that. And how about if we have this case now? Let's say we have it as this. Let's say alpha is given us, and that should be somewhat about, let's say alpha is given as 0.02, and also on the same node given as the light out. So how should we be able to have the critical value if that's the case? So now since this is the light out, it means we'll have to have the complement of this value. What would be that one? It means we'll have 1 minus 0.02. And what is that one? So that should be 1 minus 0.02. We'll have it as 0.9. So which means it should be 0.98. So which means we'll go on the table and look for the critical value corresponding to this one. I should have to say we'll go on the table and look for the value which is closer to this one, and if we have the exact value as that one, then we are lucky. But we should have to look for the value which is closer to that one, or which is the same as that one, if you have it in that table. So make sure that you have the normal table before you. And of course the value which is much closer to this one, it is given as 0.9. Now should be 0.9803. And what is the value in this case, and also what is the value in this case? So now, and up here, what is the value? And that is being given as should be 0.06. So 0.06, And what is the value here? So we'll have it as now it should be, so have it as 2.0. So if we combine, the critical value will be given as 2.06. So that is the critical value. So let's have to represent it on the, and that should be on the normal curve. And I should have to shade, and we should have to show the critical region as well as the non-critical region. You know, as far as the definition of the critical value is concerned, so this is the value that separates the critical region as well as the non-critical region, as you can see. So since the value is positive, it means it is located within this part. That is given as 2.06, and that since it is lateral, it means we'll have this case. So now this is the critical region, and this is non-critical region. So take note of that. So what if it is tuned out? How should you be able to have it out whenever it is tuned out, if this is the case? So now let's say we have alpha being given as, let's say 0.02 in the 2-dial test. How should you have it if it is a 2-dial test, if this is the case? So now, according to the principle behind, we'll have to divide that one by 2. So which means the alpha has to be divided by 2. That will be given as 0.02 divided by 2. That will be given as 0.01. That will be the value. So which means we'll go on the table and look for the critical value corresponding to 0.01. So what is that one? So 0.01, what will be the value? And of course the value which is much closer to 0.01 is given as 0.0099. So this is the value which is much closer to this one. So what is the value in this way, and also what is the value in this way? So up there we have it as, it should be 0.03, 0.03, and what is the value here? And we can have it as, now should be, we have it as negative 2.3. So if we combine the values, we'll have it as, now the critical value CV, which is given as negative 2 point, should be 3.3. That is the critical value. So now, since it is tuned out, it means we'll have a positive as well as the negative value. So in this case, since it is tuned out, it means the critical value will be presented as this. Since it is tuned out, we'll have it as a critical value is equal to plus or minus 2.33. So which means all these values will be indicated on the actually a normal curve, in the sense that we'll have it as this. So this is the normal curve, and where we'll have the negative part of the critical value being given as 2.33, and also have the positive part given as 2.33. So which means we'll have to shade the other sides. So this is the critical region, and also this is the critical region, and this is non-critical region. So take note of that if it is about 2-dial test. Now what if we have this case? Let's say we have, what if we have the alpha being given as 0. Let's say 0.5, now 2-dial. How should you have the critical value if that's the case? So now principle remains the same. Since it is 2-dial, it means we'll have to divide by the, we'll have to divide the alpha by 2. that is given as 0.05 divided by 2. What will be that one? So 0.05 divided by 2, have it as 0.026. So 0.02 should be 5. So we'll go on the table and look for the value corresponding to 0.02825 and have the critical value. Now there is nothing to subtract about with 1 because that is two-tailed test. So it is of either side. So we have the exact value 0.025. And what is the value up here? And that is being given as 0.01. And what is the value there? That is given as negative 2.8. So what is the critical value? Since it is two-tailed, we'll have it as a critical value is equal to plus or minus 2.8. Now should be a 1. That is the critical value. Then now we should have to indicate the information on the actually a normal curve, that which is given as this. So we'll have that and as that. In this case we'll have negative 2.81 and we'll have positive 2.81. We'll have to shade this region. So this is the critical region and also this one. And this is non-critical region. So now at your own time, try to have the following problems. That is at your own time. But take it from me that if it is light out, it means the alpha will be subtracted. Actually, a 1. Actually, we'll have to subtract the alpha from 1, and I'll have the value on the table. If it is left out, we don't need to subtract by 1. And at two-tailed, it means we'll have to divide by the alpha. Actually, we'll have to divide by alpha. We'll have to divide by, we'll have to divide the alpha by 2. And take the value on the table and should have to look for the critical value. And we should have a positive and minus. And as we'll be presenting on the normal curve, we'll have to indicate on both sides. So take note of that. So you should have to try the following problems at your own time. And I should have to indicate the critical region as well as the non-critical region. Let's say we have alpha is equal to 0.02. And let's say light-tailed. And we have alpha is equal to 0.04. Let's say it is a left-tailed. That should be left-tailed. And I should also have this case, let's say alpha is equal to 0.7, and that should be two-tailed test. And what if we have 0.05, and that should be left-tailed? Should be, this is the alpha like that. That should be this case. So that is the alpha which is given as that. And how about if we have this case? Let's say have 0.005. That should be two-tailed test. So try to have these problems out at your own time. Thank you.